So we're looking at the solve it. Tell whether each pair of expressions is equal by completing each statement with an equals or non-equal sign. Explain your answers. So if you look, is 34 plus 12 the same as 12 plus 34? Similarly, is 100 minus 1 the same as 1 minus 100? So as you think about the get ready in 1.4 as we keep on exploring. So before tomorrow, let me just briefly explain to you. So we're going to be looking at equivalent expressions. Those are when two algebraic expressions have the same value for all values of the variable. So as I was stating before in the previous sections, you have commutative property. Commutative means you switch the order around, as in a plus b equals b plus a. So if you look at that example, same thing for multiplication. A times b equals b times a, where a and b are real numbers, and c. So the associative property is a little bit different. It changes around the group of the add-ins or factors. It uses parentheses. So a plus b plus c is the same as a plus b plus c. You see an example. Similarly, multiplication, the quantity of a times b times c is the same as the quantity of a times the quantity of b times c. So the order of the parentheses changes around, but not the order of the numbers, like the one in commutative. And the identity properties, where a is any real number, these are ones that you've always known. They're just called properties now. A plus 0 equals a. So anything you add to 0 will always be the same number. A times 1 equals a. You multiply any number by 1, you will still get that same number. Zero property multiplication. If you multiply anything by 0, the answer will always be 0. Multiplication property of -1. You multiply any number by -1, you will always get that negative number. So -1 times 9 equals -9. -1 times 10 will give you -10, and so on. So if we look at the first problem, we want to know what property is being illustrated by each sentence. So 42 times 0 equals 0. You multiply any number by 0, you will get 0. So what do you get? The 0 property of multiplication. I'm going to abbreviate here. All right. So letter B, the next one. The quantity of y plus 2.5 plus 28 equals y plus the quantity of 2.5 plus 28. So what's being rearranged here? The parentheses. So this is the associative property. Letter C, 10x plus 0 will give me 10x. Anything I add by 0 will always give me the same number. So, and this is the identity property, I'm going to abbreviate again, of addition. All right, so now what I want you to try are the got-its. What property is being illustrated by 4x times 1 equals 4x, and x plus radical y plus z equals x plus z plus radical y. So be careful, just because they're parentheses does not mean that it's always associative. You need to look at the order, you need to look at the statement itself. All right, moving on to problem 2. So a movie ticket costs $7.75. A drink costs $2.40. Popcorn costs $1.25. What is the total cost for a ticket, a drink, and popcorn? Use mental math. So you all know how to do this, but it tells you in steps what you actually use. And you've been using commutative, associative, and all those identity properties without even knowing it. So let's look into what you actually use. So the ticket costs $7.75 plus the drink, $2.40, and the popcorn costs $1.25. So you're going to add it all together. So this example, they used the commutative property first. They switched $7.75 and $2.40. And then what they did is they used the associative property and grouped these two together. And then they simplified what's inside, and then they add to get $11.40. Now, you know how when you add stuff, you kind of switch the numbers around to make it easier to add? Well, this is exactly what they did here. And you've always been doing it. You just now know what the properties are. So why don't you try the got it? A can holds 3 tennis balls. A box holds 4 cans. A case holds 6 boxes. How many tennis balls are in 10 cases? Use mental math. And of course, you're going to be using these properties. So now we're moving on to problem 3. Simplify each expression. 3a. 5 times 3n. Now, what we always do is we want to keep the constants together. So I'm going to use the associative property and do 5 times 3n. So 5 times 3 is 15, and then you're left with n. So therefore, we use the associative property. For letter B, the quantity of 4 plus 7b plus 8. So what I want to do is combine my constants. My constants have just numbers. They don't have any variables attached to them. So what I'm going to do is first, to do it formally, I'm going to use the associative property here. After the associative property, I'm going to use the commutative property. 4 plus 8 plus 7b. Then what I'm going to do is, I'm going to now use the associative property again. 4 plus 8 plus 7b. And what do I get? I get 12 plus 7b. And that's my answer. So for letter C, what I'm going to do is 6xy over y. Now, I can do this plenty of ways. Now, I noticed that I can use the multiplication property. So therefore, I have 6xy over 1 times y. Because what do you get with 1 times y? You get y. So, and now I can split this up like this. 6x over 1 times y over y. And y over y is 1, so 6 over x times 1 will give me 6x. Or what I could have done is, as we will learn later, you notice that there is a y on top and the y on the bottom. So I'm going to cross them out, and I'm left with 6x. So why don't you try these two guides, letter A and C, in your student companion book. Moving on to problem 4, now we're going to get into counterexamples. Counterexamples is showing that a statement is false. So, in problem 4, is the following statement true or false? If it is false, give a counterexample. So it's saying for all real numbers a and b, a times b equals b plus a. Now, whether or not you think that's true, let's see. Let's look at an example, see if it is true. If it is true, then we got to do something else. So, let's have a equal 3 and b equal 5. So, 3 times 5, does that equal 3 plus 5? Well, let's look. 3 times 5 is 15, and 3 plus 5 is 8. And these clearly do not equal each other. So therefore, this is our counterexample. Let's try letter B. For all real numbers a, b, and c, a plus b plus c equals b plus a plus c. And this happens to be true because first, what do? We use the commutative property. And then we used, commutative. So first we did that. And then we used the associative. So b plus a plus c. And therefore, this is true. So why don't we try to got it? And I will show you a picture of that. So this is the got it. So try A and B. For all real numbers, is that statement true? True.